Paul Holloway here. I'm at the AS&T show in Vegas, and Ankit from Russell's behind me eating candy, and we're going to go see Andrew at PH Tool and see some of the cool things they do. Oh, there's Andrew from PH Tool. Hey, Andrew.
Hi, guys.
We're going to play a little game called What's That Weird Thing? So let's start with this. What is that?
So this weird thing is actually simulating the fir tree or dovetail on a turbine blade. We cut the piece out of a larger block of steel with wire EDM to match the geometry of the fir tree. And what we have on here on the surface is actually an EDM notch that is, actually says it on here, it's 8,000 steep, and it's 3 3/10 wide, and it's called a profile conforming EDM notch.
So what does that mean?
So that means that this notch, you look at this and you might think that something like a tool just kind of plunged straight down into this thing, but that's not the case. So this EDM notch actually conforms to the surface all the way across. It's a consistent depth of only 8 thousandths all the way across. So
wow.
It's achieved with EDM, a shaped electrode that's made specifically for this part.
See if I can get a close-up photo, and we'll see if I can get the actual profile in the end. But let's move on to the next one.
All right.
What is this weird thing?
This weird thing actually it's a pretty regular thing with weird things on it.
Okay.
So it is a sample showing our smallest micro hole that we can produce.
So where's the hole at?
So the hole is actually in the middle of this crosshair here.
How big is the hole?
The hole is 1/1000th in diameter, 25 microns.
1,000th?
Yeah, 1,000th.
So is it possible to see with the human eye, or do I need a microscope?
I mean, I can't see it with the human eye. I can kind of get a glimpse of it with an eye loop. But yeah, a microscope definitely show up.
Okay,
but,
and what about on the other side? What's that?
The other side we have our narrowest EDM notch that we can produce.
Okay.
It's called a nano notch.
Okay, and how wide is that?
That one is 6/10,000ths of an inch in width, 15 microns wide.
Wow. Now I wonder if, you know what, I think I will take a photo of this and maybe I can get that on an image too. All right, well then, and that's, what is that weird thing?
Probably one of the weirder things on our table here. This is a corrosion sample that's all made with EDM. And the EDM electrodes are very versatile because you can shape them to whatever kind of profile you want.
Okay.
So this actually was almost made like, one of our machinists is basically kind of like an artist with a Dremel tool.
Yeah.
So.
So he didn't. He didn't Dremel that. He Dremeled the electrode.
Dremel the electrode. So
wow.
The electrode makes the negative of itself. So that's what's plunged into the plate. So it's a tool that's made out of a block of graphite. And the machinist will, kind of have inspiration from a picture of real corrosion, have an idea of some of the features that might be in it, and he'll go at it with a, just a manual tool.
That's crazy.
Shape the tool, and then it's put into the machine and plunged into the steel part.
Wow. Okay, I'll try to take a picture close up and see if I can get that. And let's play part 4 of What's That Weird Thing, the final chapter. What is that weird thing?
This one here it's a pretty weird looking thing for sure.
Well, what kind of crazy person drew that?
I don't know. I mean,
that's
some
nuts.
Crazy Canadian guy.
Oh my God, it's probably in millimeters too.
Oh my God,
what a knucklehead.
Millimeters. What is it doing in the U.S.? I don't know. But anyway, this is a bunch of ASME Section 5 calibration blocks for pipe put into one. And what it does is allows you to calibrate for scanning of long seams.
Okay.
And if you look at it closely, if you kind of have a mind for how things are machined, you might think, okay, they put this on a lathe and turned bored the ID to get these steps in here.
But it's not. You're going to tell me that it's not.
It's not, because if you look at it closely, it's actually 3 different radii that are stitched together at these points here. 1, 2. So you have a smaller radius here, and you get larger radius out here as it goes back. So what it allows you to do, its compound design has a whole bunch of calibration features in one. So this one is used for covering on a pipe chart from 6-inch to 10-inch MPS.
Okay, and then there's markings on the outside.
There are, there's markings on the outside. So on the side, on the OD of this block, you'll notice that there's 9 different segments, and they are marked S1, S2, S3, up through S9.
Yep.
You'll also notice these funny little arrows everywhere, too. I'll explain those in a bit. But as far as the S numbers, what we have on the edge here is actually some engraving that kind of keys. It's like a legend how to read what section you're looking at. So you have S1, you have the thickness of the S1 segment in inches and then in millimeters. And then you have all the pipe sizes on the chart that covers. So you have 6-inch, Schedule Standard, Schedule 40, 8-inch, Schedule 20, Schedule 30, Schedule Standard. All that's covered on just this S1 segment. So you're really getting calibration for multiple pipe sizes on just this tiny little section here. And the fact that there's 9 sections means that you have a lot of calibration targets in one block.
Nice. Well, hey, thank you very much, Andrew. And I'm going to go visit the lunch line.